So we're given the diagram and we asked to find the area enclosed by this curve. So this blue part, that is what we are asked to find the area. So this is a equation on definite integral. So whenever you are given a curve, we have two formulas for that depending on the axis. This xy. You have the first curve maybe up, the other one down. So let's call this, if it's f, maybe g of x, while this is f of x. That assuming they intersect at a and b. This area bounded by this area. The area is given by integral from a to b, that is from the point of intersection. The upper function subtracts the down one, so we have f of x minus g of x dx. So that's the formula. But if is in respect to y-axis, maybe if you have these two functions, the point of intersection maybe from C to D, this one, the right one is f with respect to what as f of y, while this is g of y. That the area, this area, is the same thing as integral from C to D of fy minus gy dy. So that's what the formula we're going to use to solve this. So from this, there is a problem. We're not given the equation of these curves. Yes. So we need to get the equation of the curve. We have two curves, the straight line and the quadratic curve. So let's get the equation of the curves first. So we can use, because this is plotted, we have grid lines here. So let's find the equation of the line. So the first thing we are going to get the equation of the line. So let's call it g of x, because that's the thing. We are integrating from 0 to 6, as you can see. Their point of intersection, if you trace down, this is 6. So the integral is from 0 to 6. So let's get the equation. So the first one, equation of the line. Do you remember how to get equation of a line? Y equals ms. Okay, let's demarcate this. Okay, ms plus c, where the m is slope or gradient, and you know how to find slope, change in y over change in x, and our c is the y-intercept, that where it cuts the y-axis. So looking at this line now, we can get it fast. Y equals to change, because this is angle 90. You know, the intercept. So change in y, 12 minus 0. That's it. Y change in x is 6 minus 0. So we have 12. That's our slope now. 12 minus 0 over 6 minus 0x plus, what's the x-intercept? 0. So the equation, our equation of the line is y equals to x. So that's our g of x. That is, our g of x is 2x. So let's get the equation of the curve. So the next one is the equation of the curve. So let's call it f of x. So how do you remember? The equation of any quadratic curve is given by y equals ax minus h squared plus k, where coordinate hk is the vertex, coordinate of the vertex. As you can see, the vertex is here, yes, because the vertex is the point that divides the curve into two equal parts. As you can see, this point, this line divides this into two equal parts. Yes, as you can see, 2 to 0. This is the gap of 2, If you check again, from here to here is the same thing. So this is our vertex. The coordinate of the vertex is 2 comma minus 4. So our h is 2 and our k is minus 4. So we have y equal to a is a constant, so x minus 2 squared plus minus 4, which is, okay, that's minus 4. So, but again, we have extra points here. We have extra points. Yes, as you can see, these are to complete this, because we need to get the value of a. We need extra point on the curve, and what's the extra point here? This point of intersection, that is at what's the point of intersection here? 6 comma 12. So that's the extra points we are going to use here. So at 6 comma 12, that's x is 6, y is what? 12. So we have 12 equals a. X is 6 minus 2 squared minus 4. So let's solve for a. So solving for a implies that a is, this is 4 squared, 16. 12 plus 4 is 16. So 16 over 16 is 1. So a is 1. So the function now, the quadratic function y is now what? A is 1. So meaning x minus 2 squared minus 4, which is, open up this is x squared minus 4x. Yes, if you open up this, that's it. So our function x, f of x, is now what? X squared minus 4x. So we've gotten the two functions now. So let's integrate. So we now have that the area is the integral from 0 to 6 of the upper function. If you notice, the one up is the line, which is 2x. So 2x minus x squared minus 4x dx. Do you remember what I said? That the upper function minus the lower, so the one on top here is fs, but in the other way around is gs. So no, anyone could be fx or gs. So which is now integral from 0 to 6, 2x, this is 6x minus x squared dx. So we integrate. If you integrate 6x, is 6x squared over 2, which is 3x squared. So we have 3x squared minus, if you integrate this, is s, that's 2 plus 1 is 3 over 3 from 0 to 6. So we now substitute the upper value, subtract the lower value from there. So we have 6 squared minus 6 cubed over 3. So I've substituted this one here, minus, you substitute 0, and you know this is 0. So we now have this, that's the answer. So let's simplify. So as you can see, I'm seeing 6 squared in both. Bringing it out, we are left with 3 here, minus. If you bring out 6 squared, we are left with 6. 6 minus 6 over 3 is 2. Told you this is 0, so no need. So this is now 36 times 1, which is 36. So answer is 36 square units. So it's very simple. This is just an applied equation in integration.